we started talking about different kind of designs on executive stock options. It had two main themes. One was using averaging kind of components in the payoff, and two, basically knocking out the options out of existence uh, if certain performance criteria were not achieved during the vesting period. Let me close this one. Now we want to value them. Designs using Monte Carlo methods. Basically, we're going to simulate price paths. For each design for a given path, then average those over the possible paths. Okay. Let me use my pen for this purpose. Basically, we're going to simulate, let me actually do this in delta terms. Change in the price is equal to some sort of mean times S delta T or percentage change delta Z is a normal distribution with a mean of 0 and standard deviation of square root of delta T, where delta T is basically our sampling length. Since we will do this for 10 years, I will use weekly sampling. Basically, for that averages, we're going to calculate the average of the weekly closes, for example. Which means 520 prices. Now, for mu, we're going to take the interest rate, and for sigma, whatever it is for the firm. If you remember from our earlier stuff, let's see, we did a transformation. This is a transformation such that change in X is basically the standard normal or normal distribution. Once we calculate a path for the X's, basically unwinding that transformation. Let me see. That should be T. Let me copy all of this. Which means initial X essentially is going to be that, because initially T is 0, and once we have the X's, let's call that XT. Unwind the transformation. ST is going to be sigma times XT plus everything raised to the power E. Okay? We're just solving that XT transformation for XT. And once we have the stock prices, we got no problem calculating the payouts. So let's kind of first, let's do our setups. I'm going to call these inputs. What was I going to do? Oh. It's going to vest in 3 years. 10 years. So let's see. Just putting arbitrary numbers. Interest rate. So these are our inputs. We're going to have certain That's basically expressing 1 week in number of years. Uh, so let's calculate that, and this is r minus 1/2 sigma squared. Since we're going to use that quite a bit, interest rate minus 0.5 times volatility squared. Is that minus or plus? Yeah, minus. I'm going to give these names delta t. I'll call this E drift. I'm going to make this generic enough. Actually, we could leave it like that. Now, these are our inputs. Let me. Spot price divided by sigma. In fact, I'm going to keep using them. That doesn't matter. I'm more interested in that.